students, welcome to my tutorial video. My name is Sergio Rochalda, science teacher from Escuela de Sofia of Caloocan Incorporated. So for today's video, we are going to discuss about vector addition. But before we fully understand what is vector addition all about, we'll be defining first what is vector, and we will be differentiating vector from another quantity known as the scalar quantity. So for scalar quantity, it is defined as a quantity which has only magnitude. While when we talk about vector, it has both magnitude and direction. Remember the difference between scalar and vector quantity. When we talk about scalar quantity, it has only magnitude. When we talk about vector quantity, we are referring to both magnitude and direction. So for scalar quantity, we have distance, length, area, volume, speed, mass, density, pressure, temperature, energy, and entropy. So all of these quantities involve a magnitude only. So hindi nila kailangan ng direction for them to be said as a complete measurement. So for distance, it only refers to the total length covered by a moving object. So that does not require any direction at all. For length, area, volume, that is just a quantity without direction. Kung meron kang length, you are measuring the length of a book. Hindi mo naman sasabihin na this one is 200 centimeter north, something like that. So, hindi naman ganon at hindi nag-i-exist yung bagay na yon. For speed, it is a matter of how fast or how slow an object while it is moving. So, that is the speed. Hindi rin niya kailangan ng direction for it to said na isa siyang measurement. So, dun pa lang, the magnitude or the number itself and the unit itself can stand alone. So, for mass, density, pressure, temperature, special temperature, wala naman tayong 39 degrees Celsius west. So, parang ganon. So, it doesn't make sense. So, energy, entropy, ganon din. For vector quantity naman, it involves both magnitude and direction. Meaning to say, kinakailangan magkaroon ng magnitude at direction ng isang quantity para masabi na isa siyang quantity itself. And that is vector quantity. So for vector quantity, we have displacement, velocity, acceleration, momentum, force, lift, drag, thrust, and what we call the weight. So as you notice in the illustration, weight is a vector quantity. So pag sinabi nating weight, it involves two things: the mass of the object or the total number of molecules present on that object, and also the one that affects the weight is the pull of gravity downward. So alam naman natin na nagkakaiba-iba ang pull of gravity depending on the position of the object, kung nasaan siya. Pataas ba siya, pababa, or stationary lang siya. So it is very important for the weight to have what we call a direction. So aside from that, the force itself. So when we talk about force, you can lift an object, you can push an object, pull an object, pwede ka rin mag-lift ng paganito at paganyan. So lahat ng mga bagay na yon, or lahat ng mga way of lifting that object involves direction because it varies the amount of force that you are applying. Depende sa direction kung paano mo siya ina-apply sa mismong object na yon. So kung pahatak, paangat, depende yon. At marami tayong mga bagay na i-consider doon. At isa na nga yung tinatawag nating direction for vector quantity or for force itself. For us to know the sum or the total length, the total quantity of different vector quantities, either 2, 3, or more vectors combined together to create something sum, that is, or we have two methods, the graphical method and the analytical method na tinatawag. For graphical method, the graphical method of adding vectors A and B involves drawing vectors on a graph and adding them using the head-to-tail method. So we will be discussing the head-to-tail method in the next slide. So when we talk about graphical method, it only involves geometric figures such as lines, arrows, rays, triangles, figures. So lahat ng mga figures na pwede nating ma-imagine, dun yun kay graphical method. So this method involves line to know and to find for the sum vector or known as the resultant vector of different vector quantities. Mamaya, explain ko siya sa inyo further. For analytical method naman, the analytical method of vector addition involves using the Pythagorean theorem and the trigonometric quantities or identities rather to determine the magnitude and direction of a resultant vector. So this method also is used to identify the resultant vector by the use also of Pythagorean theorem or trigonometric identities such as the sine, yung mga cosine na yan, yung mga tangent na yan, and so on and so forth. So those are the things that you needed in order for you to use what we call the analytical method of knowing the resultant vector. So for vector addition, we will be encountering different terms na tinatawag. So we have the resultant vector. It is defined as the sum of two or more vectors. So ibig sabihin, kapag nagko-combine tayo ng mga different vectors, we are getting the sum of it. Example, in the illustration above, tignan yung illustration, we have their vector A, we have their vector B, and we have their vector C. At iba-iba yung orientation nila. Si vector A nakaturong parang paganon, vector B nakaturong parang paganito, at si vector C nakaturo na parang paganito. So, ang iba-iba sila, ang orientation nila. If you're getting the resultant vector, take a look at the illustration just above my, just above me. So, mapapansin nyo dyan, pinagsama-sama lahat ng mga vector to get the resultant vector. So, a vector addition is a literal combining of all the vectors that you have and getting the sum. So, ibig sabihin, kukunin mo lang sila, i-add mo lang silang lahat para makuha mo ang resultant vector. Ganun lang kasimple ang vector addition from the word itself. So, the process of combining or adding two or more vectors is known as the vector addition, which is our topic for today. And the tailhead method. So, let's describe or let's discuss what is a tailhead method na tinatawag natin. So, the tailhead method of drawing the vector is one way of getting the resultant vector. Actually, it is the way of knowing the resultant vector graphically. Kaya nga sa graphical method kanina, nabanggit si tailhead method because this one is one way of getting the resultant vector of different vector quantity, something like vector A, vector B, and vector C. So, paano natin ginagawa ang tinatawag nating tailhead method? So, from the word itself, the tail and the head of the arrow should be connected to one another always and forever to get the resultant vector. So, ano yung sinasabi ko na yon? So, this is a way wherein the second vector is drawn such that its tail is connected to the arrowhead of the first vector. Take a look at this illustration just above me. So, for vector A, ayan siya. From the starting point, the red dot there, that is the starting position. Kung halimbawa gumalaw ang object natin from that starting position, the red target, hanggang makapunta siya doon, malapit kay B. So kung titingnan natin ang arrangement ng mga arrows na ito, si letter B or the tail of letter B is connected in the arrowhead of letter A. So ganun daw dapat pag nag-arrange tayo ng mga vector quantities natin at para makuha natin ang vector or resultant vector natin. So we need to arrange wherein the second vector or the tail of the second vector should be connected to the arrowhead of the first vector and so on and so forth. Take a look at vector C. the tail of vector C is connected to the arrowhead of vector B. So, ganun siya lagi. And so on and so forth. So, i-connect lang natin siya. Hindi naman necessary na dapat magkakasunod silang magkakakonekta si letter A, letter B, letter C in order. Pwedeng mauna si letter C, pwedeng mauna si letter B, pwedeng mauna si letter A, and so on and so forth. So, pwede silang mauna or kahit sino sa kanila. At the end of the process, pagbalik-baliktarin mo man yung mga yan, kung sino mauuna, pangalawa at pangatlo, magka-come up ka pa rin sa same resultant vector na nakikita nyo sa screen ngayon. So, kung inunan mo man si B, inunan mo man si C, there's no problem at all because mag-a-arrive ka pa rin sa parehong resultant vector. So, mamaya makikita nyo yon sa mga susunod na slide. So, the resultant is measured from the tail of the first vector to the head of the second vector. Consider the black arrow there, dyan sa taas. So, i-consider niyo yung resultant vector na black dyan. Kung mapapansin nyo, to get the resultant vector, you just simply measure the distance or the displacement rather from the starting position, which is the red dot, to the final position or to the last or to the arrowhead of the last vector, which is the vector C. So, i-connect mo lang yon from the starting point or the starting position up to the final point or final position. Then, that is what we call the resultant vector. So, pag kukonekin mo lang sila mula doon sa starting point kung saan ka nagsimula sa unang-unang vector mo hanggang doon sa arrowhead ng last vector mo. Kung meron kang 10 vectors na pinagsama-sama mula doon sa tail ng first vector mo hanggang doon sa arrowhead ng pang-10 vector mo, that is known as the resultant vector. So, that's how we get the resultant vector graphically na tinatawag. So, we have two different kinds of vectors, what we call the one-dimensional vectors and what we call the two-dimensional vectors. For one-dimensional vectors, these are the vectors which only involves x-axis or y-axis lang. So, ibig sabihin, linear lang siya. That's why speed or that's why acceleration, velocity, yung mga yan ay classified as linear motion. Kasi nagra-run lang sila in one or naglalay lang sila in one system or in one line. So, sa x lang sila or sa y lang sila. Kaya siya tinawag na one-dimensional vector. So, for graphical method, ganun lang yung ginagawa natin. Kasi, ang ginagawa lang natin straight line. Kagaya nitong nasa illustration natin. For vector A, that's green. Vector B, that's red. If you are going to get the resultant vector of vector A and vector B, you just simply follow the tail head or head-tail method. So, inilagay ko si vector A dyan sa unang-una at si vector B sa pangalawa, which is the red one. Pinagsama ko lang sila, tail head method, nakuha ko yung resultant vector from the tail of vector A to the arrowhead of vector B. Ganon lang kasimple ang pagkuha ng resultant vector natin. For vector naman, for the second example naman, vector A violet and vector B, somehow it's orange. So, if you're going to get, ito, ibang case naman ito. So, vector A natin, the violet one, is the first vector, while the orange one is the second vector. So, in this case, the starting point is at the tail of the vector A and the ending point or the final position or point is at the arrowhead of the vector B, which is orange one. So, para makuha natin yung resultant vector, ganun pa rin yung process. Magsisimula ka pa rin sa tail ng first vector mo, which is the violet, at sa arrowhead ng iyong second vector or last vector, which is the color orange. So, kapag nakuha mo na yon, makukuha mo na agad yung resultant vector. Like sa illustration natin, dyan sa screen nyo. So, ganun lang kasimple. From the tail of the violet one to the head of the orange one. So, makukuha nyo na agad yung tinatawag nating resultant vector. So for analytical method naman, or for one-dimensional vector, ganito lang kasimple yung ginagawa natin. So let's consider the illustration or the example there in your screen. So the car, let's assume that the car traveled from point A to point B to point C to point D to point E. So ibig sabihin, mula siya sa point A, pumunta siya sa point B, then turn to point C, then after sa point C, turn to point D, then after sa point D, finally pumunta siya ng E. So, kung titignan natin, ang dami niyang stopover. Siguro, nagugutom na yung driver nitong car na ito. Pero, meron siyang mga point na pinaghintuan. So, ibig sabihin, meron siyang kino-cover na distance. Iba-iba yung kino-cover niyang distance somehow. So, to compute for the distance, for the scalar method, ang ginagawa lang natin para makompute natin yung mismong distance or scalar quantity natin. From point A to point B, that is 40 meters. Kung mapapansin nyo, mula sa A, negative 20 to positive 20b, the measurement is somehow 40 meters. So from point B to point C naman, parang bumalik siya, that is 25 meters. For point C to point D, the distance is 20 meters. And for point D to E, that is 45 meters. So if we're going to get the distance, we just simply add all of those length or all of those length covered by the car. So, lahat lang ng mga na-cover niyang distances or length, i-add mo lang yon to get the distance because it does not involve any direction at all. So, therefore, just simply add, and then after adding, you will now have the distance. And in that case, the distance is 130 meters without any direction. That is not the same with the case of displacement. Bakit ko nasabi? For displacement, let's consider the computation. From point A to point B, that is positive 40. Why? Because the taxi or the car heading to the east, heading to the positive side of the x-axis. So therefore, the value of our displacement is 40 positive or positive 40 meters. Kasi papunta siya to the right. Papunta siya to the right of the x-axis. O kung nasa right ka ng x-axis mo, technically, you are in the positive side of the x-axis. Pag nasa left side ka naman ng x-axis mo, you are heading to the negative side of the x-axis or papunta ka ng west. Ganun naman yun. Kapag papunta ka ng east, positive. Pag papunta ka ng west, negative. Pag papunta ka ng north, positive. Pag papunta ka ng south, negative. So in this case, from point A to point B, papunta siya ng east. So therefore, 40 meters siya. From point B to point C naman, that is negative 20 meters. Now, tingnan nyo, nagkaroon na siya ng negative. Those sign are just simply direction. So, sa sign pa lang, magni-negative or magpa-positive yan, nagsasabi na yan ng direction. Kasi kapag negative ang value mo in terms of one-dimensional vector, automatic na papunta siya ng either west or papunta siya ng south. Kapag positive ang iyong direction or positive ang quantity ng iyong displacement, automatic na papunta siya ng north or papunta siya ng east. So, ibig sabihin, the sign in your number tells you the direction itself. So, ibig sabihin, lahat ng positive at negative na yan ay nagsasabi sa iyo kung pa-north ka ba, pa-east, pa-south, or pa-west ka. For the case of point B to C, papunta siya mula siya sa point B, papunta siya ng point C, it's negative 25 because it is heading towards west. So, it's negative 25. For letter C to D naman, that is point C to point D, that is negative 20 pa din. Why? Because it is heading to west or it is heading towards the negative part or the negative side of the x-axis. While from point D to point E, umarangkada ulit siya papunta sa east, so therefore positive ang value natin. So if we're going to add all of this, since we are in the addition of vector, so we're just simply adding all of those values, considering their sign, so you will get positive 40 east. So kung mapapansin nyo, from point A to point E, pais naman talaga siya. Diba? Ang definition natin ng displacement or ng vector quantity to get the vector addition or vector or resultant vector. So from the starting position, which is the point A, to the final position, which is the point E. So that is our resultant vector. That is our displacement. Kaya ang displacement na nakuha natin ay from point A to point E heading towards east. And that is positive 40 na tinatawag. So 5, 10, 15, 20, 25, 30, 25, 40. So that we are correct with this one. Another example is this. The skier moved from A to B to C to D. So medyo malikot tong skier na to kasi from point A, pumunta siya ng point B, tapos bumalik siya ng point C, tapos pumunta siya ng point D. The same process yung gagawin natin kapag ganito. So from point A to B, the covered length is 60 meter or 60 meters. Habang nag-ski siya, 60 meters ang na-cover niyang distance or length. From point B to C naman, it is somehow 45 meters ang na-cover niyang length habang tumatakbo siya. At from point C to D naman, that is 60 meters. So 60 meters siya from point C pabalik ng point D. So, from point A to D, or let us just say na from point A ng pag-movement niya hanggang makamove siya sa lahat, hanggang makapunta siya ng D, that is a total of 165 meters. So, ganun kalayo yung distance na na-cover niya. So, that is 165. If we're going to consider now the displacement, ang i-measure lang natin dyan is from point A to point D. And from point A to point D, you are heading towards west. So, therefore, the value of your displacement should be negative 1. Kasi papunta siya ng west, papunta siya ng negative x-axis, or negative side of the x-axis, so marapat lamang na negative mismo yung value natin. So for that, the value is negative 75 meters west. So ilalagay natin yung west because it is heading towards west direction. So the plus the negative sign gives or tells you na papunta siya somehow in west or in south. So dalawa lang na yon. So that is for graphical and analytical method for one-dimensional. Paano naman kapag two-dimensional na? This one is quite different because it involves the x and y axis together combined. So meron ka ng x-axis, meron ka pang y-axis. So ibig sabihin pinag-combine mo sila at those two-dimensional vector na meron tayo, like the projectile motion, for you to get the motion in the projectile motion itself, or the movement in the projectile motion, you need to consider the components of the projectile motion, the x component and the y component itself. So meron kang x dapat, meron kang y, kasi ang projectile motion, di ba, pahaba, which is x, na pataas, which is y. So combine those two together, you will get, or you will have, the projectile motion. So that is same with two-dimensional vector. It involves the x and y now. Hindi na lang siya naglalay sa isang line. Either in x or y axis, pinagsama na siya. Okay. Paano natin kinukuha or paano natin ginagamit ang graphical method in identifying the resultant vector for two-dimensional vector? Tignan natin kung paano siya ginagawa. So for graphical method, two-dimensional vector, we have three methods. The triangle method, the parallelogram method, and what we call the polygon method. So for triangle and parallelogram methods, these are both applicable two vectors only. If you're adding two vectors, you can use either triangle or parallelogram depending on the situation. We will discuss that later. For polygon, that is for two or more or three or more, kahit napakarami pa niyan, pwede mong gamitin si Polygon method to identify the resultant vector graphically. So let's start with the triangle method. For triangle method, this somehow similar to a right triangle, and the resultant vector serves as the hypotenuse of the right triangle. So parang ganun lang siya pag humanap tayo ng tinatawag nating resultant vector graphically in two-dimensional vector. So Ming walks 600 meters south. Kung papansin niyo yung violet, pa-south siya. And then turns east and walks 400 meters. So the red one, pagilid naman siya at papunta siya ng east, find the resultant vector. So ano bang ginagawa natin pag kinukuha natin ng resultant vector? Ganun pa rin yung idea. Get the distance from the tail of the first vector, which is the violet one, to that arrowhead of the second vector, which is the red one. So, kung mapapansin nyo yung black na line dyan, that is the resultant vector. That one somehow is the triangle method. So, magagamit lang natin ang triangle method if and only if the two vectors are forming 90 degrees. Kasi ibig sabihin, nakakapag-form tayo ng triangle, we can use the idea of the hypotenuse as the resultant vector natin, kagaya na nasa illustration dyan. So that is for the triangle method. Ganun lang kadali yung triangle graphically pag ginamit. For parallelogram method naman, Ricky's forced. So basahin muna natin yung problem. Actually, this one is problem number 2 na. So Ricky is lifting a treasure box with a 300 force, a Newton force rather, and Alvin is also pulling the same treasure box with 500 Newton to the left simultaneously. Find the resultant vector. So in this illustration, as you notice, the starting point there is the treasure box. So si treasure box ang ating starting point. At hinahatak daw or nililift daw ang treasure box ni Ricky going to the north, of course, while si Alvin naman ay hinahatak siya going to the east. So kung mapapansin nyo, yung dalawang arrowhead natin magkaiba. So hindi siya oriented ng maayos na tail head. Pero that's okay kasi there is a way of how can we get the resultant vector by just simply arranging them. Hindi naman porkit fix na siya na ganon na yung dalawang arrowhead ay magkadugtong, dead end na para sa atin. Hindi. We can arrange this one using the parallelogram method. Paano yung ginagawa sa parallelogram method? So, from the x and y, we are just simply duplicating the x and y arrows, something like in the illustration there. So, guguhit lang tayo ng broken line na kasing haba ng x-axis natin originally at ng y-axis natin. So kung saan nagmi-meet pa rin, kung mapapansin nyo kung saan nag-meet yung dalawang tail at yung dalawang arrowhead, yun ang magsiserve as resultant vector natin for this kind of case na ang dalawang vector ay nanggagaling sa parehong point. Ang dalawang vector or ang dalawang tail ng vector ay nanggagaling sa pareho or at the same point itself. So, kapag ganyan, we can use the parallelogram method as stated and reflected in your screen. So, para siyang ganyan, na parang nagdo-drawing ka lang ng broken line at makukuha mo na yung resultant vector mo. For the polygon method naman, this is very easy. And for the polygon method, you can control anything. You can rearrange all of the vector quantities that you have. Pwede. So this is applicable for 3 and up or 3 or more vector quantities na pinagsama-sama. So let's have the problem number 3. So Mark walks 600 meter east, then turns 400 meter north, and finally walks 300 meter west. So, nilagyan ko na ng mga kulay siya para ma-distinguish natin. So, si Mark daw ay naglakad papunta sa east ng 600 meters, umakyat papunta sa north ng 400 meters, at bumalik papunta sa west ng 300 meters. Para makuha mo yung mismong resultant vector, ganun pa din. You will start to measure from the starting position, which is the red dot, up to the last arrowhead of up to the arrowhead of the last vector, which is the 300 meter west. So, kahit gaano karaming vector ang meron ka, ang lagi mo lang tatandaan para makuha mo ang resultant vector is that you need to start from the starting point or from the starting position of the first vector up to the arrowhead of the last vector. Kahit 20 or 30 pa yan, hanapin mo lang yung first at yung last vector mo. Then you can get the resultant vector. So, this one, kagaya ng sinabi ko kanina, kahit i-rearrange nyo siya, it's okay. Kasi pareho pa rin naman yung makukuha yung vector na result. Look at this illustration. So, vector A is the yellow one, vector B is the red one, and vector C is the orange one. So for the first illustration, si vector A ang naging first vector, si vector B ang naging second vector, at si vector C ang naging third vector. So kung titingnan natin yung resultant vector niya, ganyan, sa black one. For the second one, kung i-compare natin yung mga resultant vector ng first, second, and third illustration, pare-pareho lang ang orientation, pare-pareho lang lahat ng even the size of the arrow, pareho lang. Kahit na bali-baligtarin mo at sino mo una sa mga vectors mo, you will arrive at the same resultant vector. So, dyan mo palang makikita na kahit anong gamitin mo, for as long as you are correct and you are connecting all the vectors that you have orderly, in an order manner, then you will get a correct resultant vector. Kahit na anong gawin mo pa at kahit anong orientation, or rather, kahit anong order ng ating mga vector, still magka-come up ka sa pare-parehong resultant vector, kagaya ng nasa illustration ngayon. So for analytical method, it has 3, but we are going to discuss only 2, the Pythagorean theorem method and the component method only. So ito lang yung mga i-discuss natin, at anong tawag dito? Kasi yung laws of sine and cosine method is quite confusing, lalo na kapag ganito. So, we need to have a separate video for that. So, for Pythagorean theorem, madali lang naman siya. For component method, madali din lang naman siya. So, for the computation part, so pumunta tayo sa aking next video for the computation part or for the analytical method for two-dimensional vector. Thank you for watching!